Okay, so this skill here, what we're doing is we're solving equations, all right? So we're trying to find the value of the unknown. So our unknown here, right, is x. We're trying to find the unknown. And the way we're going to do this is by making the bases of the left-hand side and the right-hand side the same. Because if the base is the same, then so is the power. So here I have a base of 3. I want to express 9 as a base of 3. All right, so one way we can write that is 3 squared, right? Now because we have the same base, the base is equal, therefore the power has to be equal. And so our solution is x equals 2. All right, and so all this is a statement that if you take 2 and you put it here, 3 to the power of 2, that will equal 9. Okay, onto here we have 5 to the x equals 1 on 625. And so that might be one you're not too familiar with, but I'd go here, I've got a power of 5, so I need to express this as a power of 5, right? So we know 5 to the 1 is 5, 5 to the 2, 25, 5 to the 3 is 125, and then 5 to the 4 is going to be that times 5, which is 625. Okay, so at the bottom here we have 1 on top of 5 to the power of 4. I'm going to take it to the top of the fraction and make the power negative. Okay? And then you see we've got the same base, and so we can equate the powers. Therefore, the solution is x equals minus 4. Alright, so they'll start nice and easy like A, B, getting a bit more complex. And then when we get into things like C, it's not immediately obvious that they have a base in common, alright? But what we have to do is we may have to express both sides as a simpler base. So I'm looking at 9 and I go, oh 9, that's 3 squared, and 27, that's 3 to the power of 3. So already I'm starting to think, what's a base that they have in common? So that's going to be 3 squared, right? And I absolutely have to have it in brackets because that 2 is going to distribute to both of those in a moment. And over on this side, we'll have 1 on top of 3 to the power of 3. Okay, so we'll distribute the 2. Come on in, Sally, grab whoever you need to.
Do you have Lana Shepherd?
Yeah, I've got that back here, yeah. Okay, so we'll distribute the 2. So we're going to have 3 to the 2x take 6. Alright, that's what we've got on the left-hand side. And on the right-hand side, we're going to have 3 to the minus 3. Okay? So what have I done there? At the top here, I've distributed this power. Alright, so that 2 multiplies the x and the 3. So we have 2x take 6. And then over here, I've taken that to the top, but made the power negative. Okay, now we have the same base. I've got a base of 3 and a base of 3. So that means the powers are equal. 2x take 6 is equal to minus 3. Alright, so we can equate the powers. And then we're just solving through for x. Now we have a linear equation that we're solving, right? We're going to add 6 to both sides. And then divide both sides by 2. Alright, so I'm assuming we're pretty competent with the linear equations. We've done a fair bit of that in semester 1. If you need help with that skill, put a mark there, let me know. But what have we done? We started, we're looking here, we need to make the base of 3, expanded it, equated the powers, and then solved the linear equation. Alright, on to D. Now, whenever we have a product out the front, we absolutely have to get rid of that straight away. Alright, we just want to have a power and a power. Alright, we can't have any multiples. So I'm going to divide both sides by 3 straight away. Now, 48 divided by 3, 16. Alright, and then we need to express 16 as a power of 4. That's 4 squared. And we've got x is 2. So D a little bit easier there. Alright, so what are we doing in this skill? You know what base you have to use because that's the one you start with, right? Except here where they do get a bit more complex. So we're looking for bases in common, make the bases the same, and then you equate the powers. So give those a whirl.